Hey guys, let's look at an application of quadratic equations and sketching parabolas. So a piece of wire measuring 100 centimeters in length is bent into the shape of a rectangle. Oops. So it says let x centimeters be the width of this rectangle. So if we sketch this out, we're going to have a wire and we're just bending this into the shape of a rectangle. We know that the perimeter of this shape has got to be 100 centimeters, and we saw that the width is x. Use the perimeter, so A, use the perimeter to write an expression for the length of the rectangle in terms of x. So we need to write an expression for the length of this rectangle in terms of x. Well, to do that, let's just think about the perimeter for a second. 100 centimeters, the perimeter, has got to be equal to width plus this width plus this length plus this length. So it's got to be 2 lots of the width plus 2 lots of the length. So I've got my length in here and I need to isolate it. So I'll subtract 2x from both sides. That's going to give me 100 subtract 2x. And then to get L by itself, I just need to divide off 2 from both sides. 50 take x. Okay, so we see L is equal to 50 take x. So we'll just write in 50 take x instead here. Anyways, B, write an equation for the area of the rectangle. Well, the area of a rectangle is equal to length times width. We saw that the length was 50 take x, and we saw that the width is x. So x times 50 take x is, well, that's already an equation for the area. If we wanted to go further, we could say 50x take x squared. And yeah, we'll just leave it like that. So we can see it's a quadratic equation. C, we'll do C down here. Decide on suitable values of x. So if I'm looking at x in terms of this rectangle, what would be logical and physical values of x? Well, if it's a length, you can't have a length that's less than 0, right? So x is going to have to be greater than 0. Okay, that being said, 50 take x, so x is the width, 50 take x, the length of the rectangle. That also can't be 0 because it's also a length. So 50 take x must be greater than 0. Okay, well, if I add x to both sides, we'll see that x must be less than 50, right? Because if x is more than 50, 50 take 51, that's negative 1. Negative 1 is not greater than 0. So to keep this consistent, x must be less than 50. And we can just get that by algebraically rearranging anyways. Right, so we have two constraints. X has got to be greater than 0. It's got to be less than 50. Let's just put them together. There you go. Next is D. Sketch the graph of A versus X for suitable values of X. Okay, so let's see D. I'm just going to refer to the root format we had earlier. And I'm going to actually factor out a negative. So x times 50 take x, I'm going to factor out a negative from the brackets. So if I factor out a negative from 50, I get negative 50. And if I factor out a negative from x, I get, sorry, a negative from negative x, I get positive x, right? So have a look here, have a look here. I factored out a negative, right? Okay, so now this is kind of, I don't know, a bit more digestible, I guess. But anyways, if I draw out my axes and pick out suitable values of x, i.e. 0 to 50, well, my parabola I can see is going to be reflected about the x-axis because of this negative coefficient. And I can see that we're going to have one root when x is 0 and one root when x is 50. Yeah? So that's going to look something like this. Oh, let's try that again. that's good enough. Okay, so to find some other key features, well, we see that there's no when we look at the general format here, there's no y-intercept. Well, the y-intercept is at 0, so we see we've got the y-intercept here. It's also the value of one of our roots, so that's 2 of our key features there. Here we've got the root 50, Now we just need to find this turning point. Alright, so to find this turning point, well, the value of x at this turning point is going to be halfway between my roots, right? So halfway between 0 and 50, I can just say, what's the average of 0 and 50? That's 25. X here is 25. So when x is 25, let's check out our equation. So we'll look at this root format here. 25 times by 50 subtract 25. That's just 25 squared. I don't know what that is, but there you go. All done, sketched. Use the graph to determine the maximum area that can be formed. So we just saw that this was the axis A for area, and the maximum value that we see from this parabola is at this turning point up here. That's the highest we go along the a-axis. So the area at its highest point coincides with this turning point, which was an area of 25 squared. What will the dimensions of the rectangle be to achieve this maximum area? Well, x would have to be 25, and the length would have to be 50 take x. So it would be a 50 by 50, sorry, a 25 by 25 square is going to achieve the maximum amount of area, right? Because if x is 25, we'd have 25, and then we'd have 50 take 25, which would be 25. So it would just be a square to get the maximum area. Okay, cool. So that is... Sorry I'm whipping around so much, but I'll just pause it here. And yeah, hopefully I explained that okay.